ng-conf. You made it. We made it together. Yeah, awesome. Don't clap for me. I haven't done my job yet. So, early last year, even people outside of our usual Angular community started noticing that something interesting was happening with Angular. It kind of feels like we just woke up and got to work. What's going on here? Is there something bigger at play? I would actually argue that yes, there are two things that are making the present time a really unique time for Angular. The first is that our project is in a really healthy place. We have an amazing team, excellent leadership. Yeah. And we have an architecture that's allowing us to experiment and test hypotheses and iterate quickly on new ideas and innovations. The second thing is actually that we've been around for a while. We now have about 8 years of experience building Angular. And that's 8 years of feedback from you, our developer community, 8 years of feedback from the thousands of Angular applications at Google. 8 years that we've been able to see how the original design decisions of Angular have stood the test of time, which parts have worked well, and which parts have needed to update as the web evolves. This is really a privilege. There are not many projects in our space that have that kind of longevity and insight. So we're in a strong position right now to innovate and evolve the framework with the right team and the right knowledge. So what do we do with this? To answer that, we started asking ourselves an even more fundamental question. What is it that we really care about when it comes to this product that we build? And there's been different answers to that throughout our history. But for the team today, as we plan out the future evolution of Angular, we've realized that underlying all of our motivations is a single core principle, that we value your time and your energy. And we think you should be spending that time and energy building applications that will delight your users, not on managing or babysitting the framework. And applying this principle to Angular where it is today, we see three main areas of focus that are actually nicely interconnected. We think Angular should enable you to build high-quality and performant user experiences without needing to go in and optimize things yourself. And it should do so with an excellent developer experience. And we want to make the right long-term investments to ensure Angular can continue to deliver on these promises for the years to come. On the team, we talk about setting Angular up to be an excellent choice for the next decade of web development. 2 years ago, Jeremy and I shared this very stage and talked about how we've been taking a close look at Angular through this lens and looking at what designs or assumptions that were built into the framework since the early days need to be revisited to prepare us for the next 10 years. And we covered a number of different topics, not least of which was building a reactivity system independent of Zone.js. But today, I want to do something a little different, kind of the opposite. I want to talk about a few of the core innovations, the DNA of Angular that's still delivering value, and that we see not just as a part of our past, a part of our history, but a vital and stable foundation for our long-term future. There's any number of parts of the framework that I'd consider to be part of this DNA, but we have to get to the Q&A at some point. So I'm going to limit myself to just three: directives, views, and our compiler. There are certainly other important parts of Angular, like our dependency injection. DI is actually our highest rated feature almost every year in the developer survey. And that's actually why I left it off. I want to focus on areas I don't think get enough attention, where I believe that Angular was ahead of its time. So let's start with directives. We can trace the directive concept all the way back to the early days of Angular JS. The docs describe directives as a way to attach behavior to elements. And as surprising as that sounds, this was revolutionary back then. Today, we know directives are the building blocks of UIs, the compositional pieces that work together to describe complex applications and behaviors. They really are the driving force behind Angular's developer experience. As a quick example, let's talk about ng-model. which most Angular developers are familiar with. You can put ng-model on native input elements, or you can put them on custom controls like mat-select. But these two things, native input and mat-select, have very different APIs. So how does ng-model know how to talk to the control that you put it on? If you've ever built your own components and forms, you know the answer to this, the control value accessor abstraction. This is the API that ng-model expects all form controls to provide, and it uses to interact with them. As a custom control, mat-select can just provide itself as a control value accessor. But how does that work for native inputs, which come from the browser? It turns out there's a directive involved, the default value accessor. This directive sits on native inputs. You might not have even realized it's there, but it's adapting the native input API to what ng-model expects as a control value accessor. It's allowing this composition of the form system across all different types of components. And it's not just forms. The router uses directives for the outlet, for router links, and possibly my favorite directive in the core framework is the optimized image directive. This thing will apply automatic optimizations to your images, but there are certain optimizations that it can't do automatically, and it will guide you through how to apply those yourself. I think that's really cool. We also don't talk enough about our component development kit, a collection of directives and services that do things from drag and drop to focus monitoring, scrolling, even full-blown UI interaction patterns complete with accessibility. Directives really are the heart of the Angular developer experience. And you might even say that Angular is, first and foremost, a framework for building directives. And I've told people that, and they say, well, I actually don't write that many directives. I mostly write components. But actually, you are writing directives still, because components are just a fancy kind of directive. You might have heard us talk about this using inheritance terms, like components extend directives. And that's not just a saying. It's literally true in the code. Component extends directive.
What?
Yeah, right? So we're going to dig into that, because components are a type of directive that renders and updates a template inside of the element that you put it on. This is how it's actually working. And a great way to wrap your head around that is to build a plain directive that does just that renders and updates a template. So let's try that together. This is the component we're going to emulate. It's a display for a name input that's kind of wrapping it in some UI, probably doing some nice styling. So to make this as a directive, we're going to start off with a directive with the same input, right, and the same selector. So it's going to sit on an HTML element called fancy name. And when that directive is instantiated, we need to create the UI inside of the element that the directive is applied to. So I'm using inner HTML to do this. There are probably more efficient ways, but this is kind of the first step. And you'll notice this space here inside the span. This is going to create a text node with a space inside of it that we're going to use later to display the name. And we could put the name input here, but remember, the name can change. The input is dynamic. So instead, we need to get a reference to this text node so we can update it whenever our input changes. And we'll do that with a little bit of DOM walking, first child, next sibling, etc. And once we have that text node reference, then we can use an effect and render the name into the text node when it changes. I love signal inputs. The best thing ever. And there you have it. This is a component without @component. It's doing the exact same thing a component does, rendering a template inside of an element and updating it when the data changes. Angular really is a framework for building directives. The next item on my list, I would consider one of the most underrated and impactful concepts in Angular, the humble view. A few years ago, I was talking with Pavel from the Angular team at one of our on-sites, and I mentioned to him that I wasn't really sure what a view ref or a view container ref was. And I asked, do we really need this concept in the public API? And Pavel looked at me like I was insane. And he said, what do you mean? That is the coolest part of Angular. So let me introduce you to the magic of views and finally answer the question, what on earth is a view container? To do that, we'll go back to the beginning. At the heart of the current generation of web frameworks, all of them, is one core idea, which you might call model-driven UI. That's the idea that the UI of our application is fully described by its state. We often say the UI is a function of the current state. And we express that function as a template that shows kind of what UI to create and where the state goes. So when the state changes, the framework needs to refresh the UI. But there's a problem with this model, because to describe the UI to the browser, we create DOM. But the DOM is not a function of the same state. You can think of it that way, but it actually doesn't work in practice. For example, consider like a text input. We can render an input if that's what our state tells us to do. That's not a problem. But the moment it's on screen, the user can start interacting with it. They can type inside of it. They can focus it. They can select text. And if we recreate that DOM node, we destroy all of that state that the user created. So every framework has to solve this problem. The DOM is not stateful, or is stateful, and we can't just destroy it and recreate it whenever state changes. Instead, frameworks have to figure out how to update existing DOM on top of the templating model. So Angular has a crucial insight here. We model templates as the sum of two different types of declarations. They have a static structure. The DOM nodes that they describe should exist in their parent-child relationships. And they have bindings, text nodes, properties, or attributes that are going to update in response to state changes. So you have the static structure and dynamic points inside that structure where values can change. Remember the directive that we made earlier? It's already making use of this concept. You can see that we have the static structure, which gets assigned through inner HTML, and we have a separate effect, which is updating points inside that structure in response to state changes. And you can see this same split in the actual code that Angular would generate for a real component doing the same thing. Separate operations for creating and updating the DOM. Now you might think, wait a minute, templates aren't actually static because we have control flow. You can have an if statement that controls whether or not a DOM node exists. And this is where Angular gets really clever. We break this template into two different views. Each view has its own static DOM and its own dynamic bindings. And you can notice that the if condition is a part of the parent view. If, the control flow, is creating a dynamic binding, but instead of a binding to a property or a binding to a text node, it's a binding that controls whether or not the child view should exist. And that child view exists or not at the location of the if statement, always. So the location where the child view will exist is part of the static structure. And this is where the idea of a view container comes from. A view container is that static place inside of a view where child views can be conditionally or dynamically inserted and removed. ng-if, ng-for, if and for, etc. This static position is actually marked in the rendered DOM. Angular will create a comment node as part of your UI, and that comment node is actually tracking the place where the child views will be inserted and removed from the view container. Views have been a part of Angular since 2.0, and we're still seeing new benefits from this approach. A great example is how views impact the developer and user experiences of Angular's full application hydration. If you've used implementations of hydration in other frameworks, you might be familiar with hydration mismatches. And that occurs when the server renders one UI and the client tries to render a different one for whatever reason. And it creates a problem when the hydration process is trying to match these things up, to render with the existing DOM and find that the elements don't line up. For example, here the client wants to render a block quote element, but the server provided a paragraph tag. In many implementations of hydration, this is either an error or a de-optimization. It makes the application, the hydration, slower. Here's how you can get into this situation. This template has an if statement that's literally going to render something different on the server versus the client. And that's pretty contrived, but you'd imagine it does this because like the data is different or something like that. Now, let's look at this template from an Angular perspective. We have our if statement that's creating a view container. And depending on the condition, true or false, it will render one of the two different child views at the location of that if statement, where that comment node is. When we server render this template, we serialize not only the DOM, but also the state of the view container, which view is rendered. And that means that instead of a mismatch between elements, Angular actually sees a difference in which view the application is rendering inside the view container. And because we know the static structure, we know how to reconcile this. We can remove the server view and replace it with the one that the client requested. So in Angular, thanks to the view system, hydration mismatches are pretty uncommon. Actually, I was talking to the Angular team about this last night, and Andrew was telling me he and Doug were working on trying to create a demo of the dev tools showing hydration problems. And they spent 45 minutes trying to figure out how to get Angular to have a hydration mismatch. It just wouldn't do it. I think that's pretty amazing. One of the coolest things for us over the last few years has been seeing the wider JavaScript ecosystem pick up some of these ideas. You might have heard of ng-conf. They're building a compiler that optimizes virtual DOM rendering. And their optimization works by splitting templates into static parts and dynamic points within those static parts that update. They've posted some pretty impressive benchmarks using this approach. They call them blocks, we call them views. It's the same underlying idea. And speaking of compilers, as you might know, I worked on the Angular compiler for 3 or 4 years. That was my main project. It has a special place in my heart, so of course I'm going to talk about it. But that's also because the compiler is central to our mission of optimizing for your time and energy, and enabling you to deliver these effortless user experiences with a great DX. It's one of the most important tools we have because it allows us to decouple these things, to evolve the developer experience independently from the user experience. To understand what I mean by this, let's look at one of our newest features, right? Deferrable views, defer blocks, which enable template-level lazy loading. Let's say we have a template, which is going to display a user profile, and we have the user's name and a biography, and we expect our biography is going to be quite long, maybe some scrolling involved. After that, we have a component that's going to display some profile badges. And we know that these badges aren't as important as the rest of the page. We want to make sure that they don't block the rendering of the rest of the application, so we want to lazily load them. And we want to show them when the user scrolls the page enough that they would be in view. This has been possible in Angular, actually, since Ivy, about 9.0. But it's never been for the faint of heart. These are the steps we'd have to go through to do this ourselves manually. Right? We have to create a placeholder that we're going to track where it is in the view. We have to query for it to get a reference to it. And then, if you're like me, you have to go get a coffee and curl up with the docs on Intersection Observer for a while to figure out how to actually query if an element is in the viewport or not. What's wrong with this? You might say that's a lot of boilerplate, that's a lot of complexity or hoops to jump through, but we think about this in a pretty specific way. You have a problem, and you have to describe to the framework how to solve your problem, how to do the thing that you want to do. And you have to do it in the language of queries and template refs and view containers and dynamic imports, the language the framework and the platform speak. And translating your problem into that language takes up your time and energy that you could be spending on other parts of your application. So with Defer, we set out to design a better API and design it in a different way. We wanted an API where developers could tell us in their terms what they want to accomplish. So here's what that looks like with Defer. We wrap the badges component in a defer block. We declare a loading placeholder. We set the condition, show this on the viewport, and we're done. It's so much less work, so much less effort to tell the framework what to do. And I don't have to spend my afternoon reading Intersection Observer docs, because I can just tell Angular what I care about in my terms, and the framework figures it out. Our compiler then comes along, interprets your defer block, and translates it into the right actions to make this happen at runtime. So here, for example, the compiler is generating the dynamic import for you. You don't have to think about it. It's also adding an instruction in the creation mode, the static part of this view, which sets up the intersection observer to watch for the placeholder to enter the viewport. Again, so you don't have to do it. This approach has another huge benefit. The best practices for lazy loading on the web can and do change. Maybe there'll be something better than intersection observer in a few years. Maybe we'll get something different than dynamic import. When you express your intention instead of hard coding the steps to do something, it gives Angular the freedom to change our implementation over time to keep up with the web's current best practices automatically under the hood. Another area where we see our compiler dramatically improving the developer experience is in our type checking of templates. Let's look at another recently added feature, ng-model. Two-way data binding directly to signals. It's not just ng-model, all two-way data binding does this. This is really convenient to use, but it created a problem for our type checking. How do we type check this binding when the type of data can be different? We support binding to signals, but we still want to support binding to plain values. And more importantly, we want to give you a clear and actionable error message when this is wrong. And to make sure we give good error messages, we actually use TypeScript under the hood. So our compiler is able to define, create code under the hood that describes to TypeScript what you're trying to do. And then we ask TypeScript to produce error messages for us. So here's a snippet of the code that roughly represents the operations involved here, creating an input, an ng-model directive, and setting the input to the value of the data property. And you can see that when we attempt to assign data into the ng-model input, TypeScript will tell us whether this is right or wrong, and we can report that as an error in your template. But this way of checking doesn't handle signals yet. It's going to check whether writable signal itself is assignable to ng-model, probably not what we meant to do. Because our compiler is generating this code, translating the intention of your templates to TypeScript for type checking, we can just change the generated code. Here, we've wrapped the binding expression that we're checking in a utility that's going to unwrap signal types if needed. And that way it type checks correctly. Having our compiler in the middle like this is a big reason why we're able to add these kinds of features without breaking existing applications. It's one of the reasons why we're able to get model in a minor release. Yeah. So we've talked about directives and how they're the building blocks of great user and developer experiences. We've talked about views and how this architecture of creating and updating UIs is powering our rendering engine. And you saw how our compiler is acting as a bridge between your intentions and our features. We are not done evolving these technologies either. You saw in the keynote that selectorless directives is something we're looking at that's on our roadmap. And you maybe have heard about signal components and the concept of per view change detection. We're really focused on building Angular as a framework for web applications for the next decade of web development, but we're doing it on top of stable foundations, our DNA, these innovative ideas that continue to power the framework and deliver new value. It's been an absolute privilege to present the last talk of the conference here, and I hope you'll stick around and talk to us in the Q&A panel that's coming up next. Thank you very much.
Can we give a round of applause? Do one more time for this man and the team that has brought us this framework. Amazing. All right, we are going to set up for Q&A, yeah?
No.
Oh.
We have a sponsor talk.
I forgot all about it.
But I have a quick question. Who's excited for the future of Angular?
Oh.
It's just Mike. No, I didn't see any other hands. I heard and saw Mike jumping up and down over there. But before we get to the panel, we do have another sponsor to hear from.
Yes, they're oh so useful. I love them a lot.
Yes. So, from Stack Blitz, please welcome Alex to the stage.
Come on up, Alex!
Hey everybody, I'm Alex from StackBlitz, and if you are not familiar with the StackBlitz tool, I don't know where you've been, because we're powering most of the open source stocks, including, very exciting, the new Angular.dev interactive tutorial mode. Which, if any of you want to build something like that, let me know. But for those of you who are not familiar with StackBlitz, we are an in-browser code environment for front-end web development. And we can be used for many things, from building interactive tutorials, doing job interviews, bug reproductions, live examples in docs, prototyping, working with designers, on and on and on. But this is the last sponsor talk of the day, and instead of rambling on and on about, why you should buy StackBlitz for your enterprise, I thought instead, why don't I tell you a quick story? So today, I'm going to tell you a story about a developer named Jake. And Jake has been tasked with building a UI library or design system for the large organization that he works at. And so he sits down, he builds the library, and he spends countless hours on Zoom calls and email threads working with folks like all of you, trying to get you to adopt this UI library that leadership has said we must all use. And it takes him a lot of time and a lot of work, but he perseveres and gets most of the organization to adopt this new UI library. However, disaster strikes. He's getting buried in inbound requests, bug reports, and issues people are having adopting the library into their applications. And he's spending hours of his week loading up the mono repos, jumping into other people's branches, and trying to figure out what the issue is, recreate it so that he can go ahead and take care of it. But what do we see over the horizon? There's StackBlitz riding in to Jake's rescue. We're gonna knock this problem out for him. So, boom, all of a sudden, Jake has live examples in his documentation, so every developer with a single click can pop open every component, play with it, change the props, mess with the CSS, make sure they actually understand how to implement the thing into their application, and that drives bug reports to the UI library team way down. But, there's always going to be a few, and for the ones that do come in, they are now replicated for Jake inside StackBlitz, so he can review them with a single click. And even better, Jake now actually has time to innovate on the library and implement all the cool new things that he learned about Angular at ng-conf. So, in conclusion, the moral of this story is, if you are a Jake or you have a Jake at your company, don't let him suffer alone. Let him know about StackBlitz. Send him over to the website. We've got live chat, and it goes straight into my Slack, so he'll have no problem getting in touch with me, and we'll work together to get StackBlitz implemented for your organization behind your firewall, integrated with all of your enterprise developer tools that you're already using. And, Jake will be a happy developer. So appreciate all your time. Enjoy the rest of the conference. And
Thank
everybody
you so much.
Put
it together for StackBlitz.